Hello everyone, hope you're all doing fine. I came back with another lecture on electrostatics. In the previous lectures on electrostatics, we have learned about the forces and the fields due to the point-sized charges. But more often, we find the objects with distributed charges. This charge distribution on the bodies or in the bodies is usually described with the help of charge densities. Charge densities. In this video, we are going to learn about three different types of charge densities. Okay. So yes, my name is Vijay Krishna and you're watching up this channel. Let's get started. Okay. First, let us understand the first type of charge density, that is linear charge density. Linear charge density. This linear charge density is usually represented with lambda. It is usually represented with lambda. Let us take a line object. Let us take a rod. Let it be a rod. Okay. I've taken a rod of length L. Of length L. Okay. Of L length rod, I have the charge Q. Total charge on the rod is Q. Now, on the length L, I have the charge Q. On length L, I have the charge Q. Now, per unit length, what is the amount of charge? That is Q by L. It is simple, basic calculation, like if the cost of 20 pence is 100 rupees, what is the cost of each pen? That means 100 by 20. So per unit length, what is the charge distribution? That is Q by L. This ratio of charge to length is called linear charge density. Linear charge density. I'm going to define this linear charge density again. Okay. Charge distributed on the line object, linear object, as you can say, line object or line object per unit length, is called linear charge density. Linear charge density. Linear charge density. So this is how we define the linear charge density. Very important definition. And the formula for linear charge density is the already obtained. Lambda is equal to Q by L. Lambda is equal to Q by L. This is the general formula for the linear charge density. So if I want to express this linear charge density in calculus form, instead of taking the entire rod's charge, I am going to take small element charge. Let's suppose I haven't taken the entire rod. I have taken only a part of the rod whose charge is dq. Small charge, tiny, small charge, and its length is dl. Let it be. If it is aligned along the x-axis, I usually represent with the dx. If it is aligned along the y-axis, then I will take dy. If it is along the z-axis, then I would use dz. Okay. So dq and dl. dl is the length on which charge distributed is dq. Okay. Per unit length, what is the amount of charge that is distributed? Dq by dl. Dq by dl. This is again called linear charge density. Linear charge density. Okay. So dq by dl. I'm going to rearrange this equation for charge. dq is equal to lambda dl. Lambda dl. I can use q by l. I can use q by l for lambda here. But anyhow, dq is equal to lambda dl. If I want to find the entire charge, I have to integrate. I hope the steps that I have followed are clear, right? Are understandable. Now, let us understand this linear charge density even further. Okay. So, what is the unit of linear charge density. Linear charge density. It is obviously a scalar quantity. It is a scalar quantity because q is scalar, length is in the denominator, so it is a scalar quantity. So, what is the unit of linear charge density? Unit of lambda. Unit of lambda. By looking at the equation, looking at the formula, you can get the units like unit of charges coulombs, unit of charges coulombs, and unit of length is meter. Coulomb per meter is the unit of linear charge density. Okay. Now coming to the dimensional formula. Dimensional formula. Dimensional formula of lambda, linear charge density. What will be the dimensional formula? Again, you need to look at the equation. Okay, there is q is not a fundamental quantity, rather it can be expressed in terms of fundamental quantities such as current and time. So dimensional formula of q is a l I sorry a t a t. Okay, because q is equal to it. A is the dimensional representation of current, T is the dimensional representation of time. Okay, so A times T, and the dimensional formula for length is L again. Okay, dimensional representation of length is L. Now, now the dimensional formula of lambda. Dimensional formula of lambda. Lambda's dimensional formula is charge dimensional formula AT by length dimensional formula L, which would turns out ATL minus 1. ATL minus 1 is the dimensional formula of linear charge density. Unit and dimensional formula. Okay. Now, dimensional formulas are a kind of very important when it comes to NEET exam, but dimensional formulas are not directly asked in mains exams more often. But to find the dimensional formula of unknown quantities or unknown physical quantity or unknown terms in an equation is a very famous question. It frequently appears in most of the mains exam. Okay, so ATL minus 1 is the dimensional formula of linear charge density. Now let us see some of the examples where we use this linear charge density. For example, charged rod, as I've taken charged rod, and charged charged thin wire, and charged ring, some sort of line charges. We use linear charge density. Okay, I hope this entire analysis explanation is very clearly understandable, right? Now let's move on to the next type of charge density, which is surface charge density. Surface charge density. Surface charge density. Okay, surface charge. How do we define this surface charge density? Actually, when it comes to surface charge density, we look at the charges distributed over the surface of the bodies. Over the surface of the bodies. If you take any object of surface area A, the amount of charge distributed is Q. Let us suppose charge distributed on any surface area, any object of surface area A is Q. Then what is the amount of charge distributed per unit surface area, which is Q by A. Q by A. This Q by A is nothing but surface charge density sigma. I forgot to tell you, this surface charge density is usually denoted with sigma. Sigma. Okay. Q by A. So how do we define this surface charge density? Surface charge density can be defined as charge distributed per unit surface area. Unit surface area is called surface charge density. Surface charge density. Okay, surface charge density is denoted with sigma. Its formula is charge per area, charge by area. Okay, so its definition is charge distributed per unit surface area of the object is called surface charge density. Now let's understand the surface charge density little further. What are the units of surface charge density? Unit of sigma, which is surface charge density. Sigma is given by the formula charge per unit area, charge by area. So the unit of charge is coulomb, charge is coulomb, and the unit of area is meter square. Unit of area is meter square. Okay, coulomb per meter square is the unit of surface charge density. Surface charge density. Now coming to the dimensional formula, dimensional formula of sigma. Dimensional formula of sigma. What will be the dimensional formula of sigma? As I've already told you, the dimensional formula of charge is A times T. Q is equal to IT. Dimensional formula of charge is AT. And the dimensional formula of A is ampere. Not ampere, it is A is area. Area's dimensional formula is L2, length square, because areas turns out to be pi r square, side square, length into breadth. So it is always meter square. Unit is meter square, so the dimensional formula will be L2. If I rewrite this equation, ATL minus 2 will be our dimensional formula for the surface charge density. Surface charge density. Okay, so the formula for the surface charge density is Q by A, and its definition is already given here, charge distributed per unit surface area. The unit of surface charge density is coulomb per meter square. The unit of dimensional formula is ampere time, ATL minus 2, L minus 2. And the calculus form of surface charge density is not discussed here. Calculus form of surface charge density, if I would have taken any surface area, let's say I've taken a hollow sphere, I've taken. If you take any portion of surface area whose area is dA, and the charge distributed over this surface area is dq. If dA is the area on which on which the charge distributed is dq, then per unit surface area what will be the charge distribution, which is again dq by dA, and we call this ratio as surface charge density sigma. Surface charge density sigma. Okay, so this is the calculus form of surface charge density. If I want to rearrange this equation, dq is equal to sigma dA. Okay, sigma dA. This is the equation where small elemental charge, small areas involves. Okay, even you can use this sigma is equal to k by a and replace it over here for further analysis as well. If you want to find the total charge, you can even integrate. Okay, you can even integrate. Right, I hope the steps followed are clear, right? Okay, so this is all about surface charge density. If you want to ask a question like where do we use this surface charge density, so let us suppose we use this surface charge density when we have the bodies with charge distribution over the surfaces. Okay, not the entire body. So charge distributed on the surface of the hollow sphere. Charge on hollow sphere. Okay, infinite thin sheet. Sorry, charged, charged, charged thin sheet, thin sheet. Okay, thin sheet, and capacitor, parallel plate capacitor, parallel plate capacitor, parallel plate capacitor. Surface charge density, we use surface charge density while we discuss the concept of charge on hollow sphere, charged thin sheet, parallel plate capacity, capacitance of parallel plate. So parallel plate capacitor. While we discuss these kind of concepts, we use surface charge density. Okay, right. Now let's move on to the next type of charge density, which is volume charge density. Volume charge density. Okay, volume charge density. Volume charge density. It is usually represented with rho. Rho. What is it? Rho. Sorry. It is usually represented with rho. Okay. Now, let in this case, while we deal with volume charge densities, the charge has to be distributed over the entire volume, in the entire volume of the object. Then only we use this volume charge density. Okay, volume charge density. Okay, volume charge density. Let's say V is the volume on which the charge distributed is. V is the volume on which charge distributed is Q. V is the volume on which charge distributed is Q. Per unit volume, how much amount of charge is distributed? Again, Q by V. This Q by V ratio is called volume charge density rho. Volume charge density rho. How do we define this one? Charge distributed in I mean charge distributed unit volume per unit volume of the object is called volume charge density. Volume charge density. Okay, volume charge density. We have obtained the formula and we have also defined this volume charge density. Now, if you want to write the calculus form of volume charge density, how would you write it? Rho is equal to dq by dv, where dv is the small amount of volume in which the charge distributed is dq. The ratio of dq and dv is nothing but volume charge density. Okay, so this will be our calculus form of volume charge density, and if I want to rearrange this equation, dq is equal to rho dv. If I want to find the entire charge of the object, then I have to integrate. Okay, hope the steps are clear to you. Right, now let us find the unit. Let us define the unit of rho. Unit of volume charge density. What will be the units of volume charge density? It is Q by volume. Q, the unit of Q is, unit of charge is coulombs. Unit of volume, meter cube. Unit of volume, meter cube. This will be our units. Okay, now coming to dimensional formula. Dimensional formula of rho. Okay, so rho's dimensional formula will be, as you can see in the formula, we have charge on the numerator. The dimensional formula of charge is A times T. And the dimensional formula of volume, usually the unit is meter cube, so the dimensional formula of volume will be L3. Dimensional formula of volume will be L3. If I rewrite this ratio, A T L minus 3. This will be our dimensional formula of volume charge density. Okay, so we have obtained the formula for the volume charge density, both general form and calculus form, and we have defined the volume charge density, and we have defined the units and dimensional formulas of volume charge density as well. Okay, So the now the question is, where can we use this volume charge density? Example, um, charged charged solid sphere, charged solid cone, etc. Okay, charged solid sphere, charged solid cone, etc. In such, while we studying such objects, we use volume charge density. So, in this lecture, we have learned about linear charge density, surface charge density, and volume charge density. All three types of charge densities. Basic, three types of charge densities. So, linear charge density formula is lambda is equal to charge per unit length, charge by length. Surface charge density formula is sigma is equal to charge per area, Q by A. Volume charge density formula is rho is equal to charge per unit volume, charge by volume. Okay. Now we have already also learned about the dimensions and the units as well for each of the charge density. Okay. I hope fundamental definitions of linear, surface, and volume charge densities are very clearly understandable. If you find the video is really helpful, please do like, share, subscribe. Okay, and don't forget to hit the bell icon in order to get the notifications as soon as I upload the videos. That's it in this video. See you in the next video. Thank you for watching.